The sides of a rectangle are given by the equations x equals a, x equals a prime, y equals b, and y equals b prime. Determine the equation of its rectangle. Now let us begin. First, we'll try to understand this problem graphically. So here we have the coordinate axis. Now let's begin with the first equation, x equals a. Now let's say we consider a point on the x-axis in the positive direction and let this point correspond to x equals a. And then we'll consider another point on the same x-axis, a prime, assuming that a prime is greater than a. Now, what is the graph of the line which is denoted by x equals a? We always know that whenever we have x equals to a, so this is going to be a line which is going to be parallel to the y-axis. Similarly, for x equals to a prime, this is also going to be another line which is going to be parallel to the y-axis. So let's draw two lines passing through the point x equals to a and x equals to a prime and parallel to the y-axis. So here we have the two lines x equals to a and x equals to a prime. Next, we will consider a point on the y-axis and let this point be b. And we'll also consider another point b prime on the y-axis as well. And this particular b prime value, let's say it's greater than b. This is an assumption. Okay, now what we'll do, we're going to draw a line which passes through the point b and b prime, and this is going to be parallel to the x-axis, because we know that any line whose equation is given by y equals to b, so that's a line which is going to be parallel to the x-axis. Similarly, for the other equation y equals to b prime, that's also going to be a line which is going to be parallel to the x-axis. Okay, now let's sketch the two lines. If we consider the line x equals to a and we consider the line, so this is y equals to b and the upper line is y equals to b prime. So the line y equals to b and x equals to a, let's say it intersects at the point a. So point A will be having the coordinates which is nothing but the intersection of the two lines. So the x coordinate will be A and the y coordinate will be B. Then we have the point B where the line y equals to B and x equals to A prime intersects. And that means the coordinates of point B will be the intersection of the two lines. So that's simply x equals to A prime and the y coordinate will be y equals to B. Then we go to the third point C. So let's say C corresponds to the point where the lines x equals to a prime and y equals to b prime intersect. So that means the coordinate of point C is going to be a prime comma b prime. And we have the fourth point, point D. The D is going to be the intersection of the two lines x equals to a and y equals to b prime. So we have a comma b prime. That's going to be the coordinates of point D. So now we have a rectangle ABCD where the 4 points are given to us. Our goal will be to obtain the equation of its diagonal. So let's say we join A and point C. Now that's going to be the diagonal AC. Similarly, we can join B and D. That's going to be the diagonal BD. We'll start by computing the equation of the diagonal AC. Equation of AC. Now how do we find out this equation? We're going to take the help of the two-point form of a line. So let's quickly recapitulate what's the two-point form of a line. So let's say we have a point with coordinates x1 comma y1 and we have another point x2 comma y2 are its coordinates. If we have a straight line that passes through these 2 points, then the equation of that line will be given by y minus y1 equals to y2 minus y1 divided by x2 minus x1 whole multiplied to x minus x1. So we can use this particular formula to find out the equation of the diagonal. So let's start with the diagonal AC. Now that means we will only need the coordinate points A and C. Fine. So what we'll do here, we'll assume that let's say x1 comma y1, these are the coordinates that corresponds to point A, and C corresponds to the coordinates x2 comma y2. This is going to help us obtain the value of x1 y1 and x2 y2. So we have y minus y1. So y1 will be the y coordinate of point A, so that's b. This will be equals to, now we need y2 minus y1, so that's b prime minus b divided by x2 minus x1, so that's a prime minus a. This will be multiplied to x minus x1, so here x1 will be simply a. Okay, now let's cross multiply y minus b with a prime minus a, and on the left hand side we have x minus a times b prime minus b. So we can further simplify this. So we're going to expand. So we have y times a prime minus a minus b times a prime minus a. And on the left hand side, we have x times b prime minus b minus a times b prime minus b. Okay, so we have x times b prime minus b. All we're doing is we're rearranging the terms. Minus y times a prime minus a plus b times a prime minus a minus a times b prime minus b equals to 0. So we have x times b prime minus b minus y times a prime minus a. So let's combine them. So we get b a prime minus a b prime equals to 0. So this is going to be the equation of diagonal AC. Now what we'll do, we'll try to find out the equation of the diagonal BD. So that means we need these two coordinate points. So here let's choose B as x1 comma y1 and D as x2 comma y2. We'll substitute into our 2-point form. So we get y minus y1 equals to y2 minus y1 divided by a minus a prime. So that's x2 minus x1 multiplied to x minus x1. So that gives us y minus b multiplied to a minus a prime equals to x minus a prime times b prime minus b, which gives us y times a minus a prime minus b times a minus a prime equals to x times b prime minus b minus a prime times b prime minus b. We get y times a minus a prime minus b times a plus b times a prime equals to x times b prime minus b minus a prime b prime minus a plus a prime times b. So here immediately a prime times b will get cancelled out from both sides. We're going to rearrange the terms to get x times b prime minus b minus y times a minus a prime plus ba minus a prime b prime equals to 0. So this is going to be the equation of the diagonal. Hence, we have successfully obtained the equation of the two diagonals of a rectangle using the 2-point form of a line.